So, this is how we have expanded our circuit for Project 2. We have built a rig that will be used to move around the array for sampling an area, though right now we are moving around a magnet over the array for testing. The second part is what we are also testing with is a bunch of wave charts showing what each Hall sensor is seeing rather than just being hooked to a comparator. And then the final step was we actually built an algorithm that centers the carriage over the middle Hall sensor. So here's a block diagram of our second project. So we have three basic pieces. First, in the manual mode, we are controlling the rig with user interface through LabVIEW. So we have the user interface going to the computer, which through the LabVIEW software is controlling the LEGO NXT, which is controlling the first and second motors. Then for the graphing, we have the sensors running into the computer through the lab jack, and then with LabVIEW we are graphing each sensor's detection. Finally, in the automated mode, we have the sensor going into the computer, again with lab jack. Then with LabVIEW we are going through a centering code or algorithm, and then that's controlling the NXT, which is controlling the first and second motors, and then this is looping around to continue as long as we have the program running.
The rig consists of one frame and two carriages. A LEGO Mindstorm controls a pulley that moves these rigs up and down and left and right. The rig is made of three types of materials: Legos, PVC, model train parts. The rig will be used to test the sensor and later on move the sensor. So here we have the software for the graph. Basically it's broken into 5 components. One component for each sensor. Here is the output. When I hit run, Travis will move a metal by the sensors and the graphs will react accordingly. You can see them on the left side of each graph.
Okay, so this is the centering algorithm. Let's get to the block diagram. So it starts over here. All this is just logic that basically assigns each one of the Hall sensors a different number. And it comes over here to a case structure so that when the right sensor sends its number, it's going to do the case of moving the motor to the right or to the left, depending on how we have the inversion. When the left sensor sends its number, it's going to be the case to move it to the left, and so on, so that basically no matter which one of the sensors detects, it's going to be moving it towards the middle sensor, which when it's centered, that will send the stop command. We also wired in a second case over here that we can do a manual override if things are going haywire. Very important. Okay, and here we have our fully interactive circuit that I'm going to move the sensor array. There's a magnet attached to the innermost carriage, and it's going to follow it like the program should. So if I move this to the right, it's going to follow it to the right. If I move it to the left, follow it to the left. If I move it forward, it's going to follow it forward. Try to center it. If I move it back, it's going to follow it back. Yeah.
Okay, so there's a few things I learned. With something this complex, planning is key. Well-made diagrams are very helpful, and the graph chart is the best thing to use for real time.
Okay, so here we are back at the computer with the centering algorithm. There are a couple things that we learned about programming that was very interesting. So Dr. Matt actually came by, and he and Dr. Bensky both were looking at our program and some of the things that we could do, and we had a ton of cases just down the line. It was really complicated, really confusing, and it wasn't really working. And they found out that you can actually, instead of having the case structure be just true-false, you can have it be assigned to different numbers. And so that, like I said earlier, we have each sensor to a different number, and they are all being added together, coming in to determine which case we're going to go into. The one other thing that was very interesting is that so we wanted each sensor to have its own number, but also if we have a combination of sensors on, we want them to each sum to a unique number. And I tried different things and eventually found, and it should have been obvious, that you can actually just follow binary is the best way to do it. So you have 1, 2, 4, 8, 16, and so below 4, these will sum to everything below 4, these will sum to everything below 8, these will sum to everything below 16, and there's no crossover. It's exactly what we were looking for.